Hello everyone, welcome back to Diksha Karnataka YouTube channel, and today I am going to discuss a very important thing, that is your model paper number 3. I have already completed model paper 1 and model paper 2. If you have not watched them, go and check them out. Now before starting this video, I want to clarify one common question that I received from most of you. Sir, is model question paper enough for me to score 70-80% in PU board exam? Answer is no. And many of you ask that, sir, is it enough for me to pass model question paper? If I study model question paper, will I pass in the PU exam? If you study all the 3 model question paper, definitely you can expect to get at least 21 marks. Why I am saying that? Because last year question paper, if you see, there was no MCQ in common from the model paper. Last year there was only one model paper available, and from that we have a few 2 marker, 3 marker and 5 marker questions from model question paper. Some numerical which is similar to that of the model question paper, not exactly the model question paper. So if you have completed entire model question paper, you could have scored like 21 marks from the model question paper. Okay, so 21 marks is possible from studying model question paper, but this year we have 3 model papers. So I am expecting that if you study all the model papers thoroughly and remember the answers, maybe you can score up to 30 to 40 marks. But why should I study model question paper? There are 2 reasons. That first of all, it gives you a practice material. You can practice from this model question paper, so this is a very good practice material. Secondly, the question pattern, if you see what question will come from, or to what type of 2 marker questions we can expect, what type of 3 marker question I can expect, what type of numericals I can expect, that will be covered in this model papers. So all the model papers, if you study 3 model papers, it will help you to understand the patterns, question patterns, similar questions. Okay, the language might slightly change from the model paper. So but if you study all the 3 model paper, you can score up to 30 marks easily. That is in my expertise, that is telling me that this year if you study all the 3 model papers, 30 to 40 marks you can score. Okay, but if you want to score out of out, model paper should be your guide, not your study material. Okay, so let's start with the model paper. So first, obviously as usual, we will start with the MCQ section. First is 1 marker. The SI unit of surface charge density. What is surface charge density? Very important. There are 3 types of charge density. So in the model paper they have given surface charge density. Maybe exam you can get a volume charge density. So these are the small types of change that you can expect in the final paper. So surface charge density is charge divided by surface area, right? That is surface charge density. So what is the unit of charge? Charge unit is coulomb. What is the unit of meter? Area is meter square. So unit of area is meter square, but it is in division. So coulomb per meter square, or coulomb meter to the power -2. So that is the unit for surface charge density. Easy. Now the values of electric field E and potential V at any point on the equatorial plane on the electric dipole are such that E equals to 0, V equals to 0, E equals to 0, V not equals to 0, E not equals to 0, V equals to 0, E not equals to 0, V not equals to 0. So on the equatorial plane of a dipole, what is equatorial plane? If you remember, this is called equatorial plane, and at that point the potential was 0 because this is plus, this is minus, and equidistant. So potential was 0, but electric field was not 0. Electric field had some value, a negative value in fact. So electric field is not 0, electric potential is 0. The potential difference across a capacitor is doubled, then the energy stored in it. So what is the energy stored in a capacitor? It is half CV square. So potential difference is doubled, that means C is constant. So if you double the potential difference, then it will be 2V square, that is it will be half CV square into 4. That is, it is quadrupled. Okay, so this is called quadrupled. Quadrupled means 4 times. Okay, so this is the answer for question number 3. A wire has a non-uniform cross-sectional area as shown in the figure. a steady current I flows through it. Which one of the following statement is correct? So what is the figure? Let me draw the figure once. Okay, figure is missing here, but I remember the figure, so I can draw the figure. Okay, so the drift speed of electron is constant. The drift speed of electron increases while moving from A to B. The drift speed of electron decreases while moving from A to B. The drift speed of electron varies randomly. Now if you see that the area, cross-sectional area at A is smaller than cross-sectional area at B. Now what we know that I equals to NEAVD. Okay, or drift speed, here I is constant, a constant current is flowing, so VD equals to I by NEA. Now NE is also constant, so what we can see that drift speed is basically proportional to 1 by area. Smaller the area, larger is the drift speed. So what is the meaning of inversely proportional? Inversely proportional means smaller the area, larger the drift speed, larger the area, smaller is the drift speed. So drift speed will be large here because area is small. Drift speed will be smaller here because area is large. So drift speed of electron decreases while moving from A to B. So option C is correct answer. So drift speed here will be high, here will be low. So drift speed basically decreasing. Now next question, a table based question. A charged particle of charge q, there is a lot of statement mentioned here. Charge q in a moving uniform magnetic field, the angle between the velocity v of the charged particle and the magnetic field B is theta. The trajectory of the charged particle varies with angle theta. Match the following table by choosing the appropriate trajectory traced by the charged particle for different possible values of angle theta. So here they have given theta equals to 0, theta is equal to 45 degree, theta is equal to 90 degrees. So for theta is equal to 0, we know that this is the straight line, and theta is equal to 90 degree, we know that this is a circle. So circle is basically this one. Okay, so option A, and straight line is for when angle is 0. So definitely number 2 will be C, that is 1 with B, okay, 2 with C, 1 with B, 2 with C, 3 with A. So option B is the correct option. Okay, so option B is the correct answer. 1 with B, 2 with C, and 3 with A. Okay, next, now it's a statement based question. Below are two statements related to magnetic flux and magnetic field lines. Statement 1, the net magnetic flux through any closed surface is 0. Yes, correct statement. This is a correct statement. The number of magnetic field lines leaving the surface is balanced by the number of field lines entering it, or vice versa. So if you consider the closed surface, what happens is that the net magnetic flux through this is always 0. If the surface is closed, net magnetic flux will always be 0, because whatever the number of field lines entering it, the same number of field lines has to exit it. There is no other way. Okay, that is why net magnetic flux is 0. So the field lines is, if you consider the field lines is basically the electric flux, but there is no net electric field lines passing through a surface. That means the flux is 0. So this is the correct explanation. Not only this is the correct statement, this is the correct explanation as well. So both statement 1 and 2 are correct, and 2 is the correct explanation for option 1. This type of questions are considered to be HOTS question. So you have to be prepared for this kind of questions, and while answering such questions, you have to think at least 2-3 times that whether the statements are correct or not. Now, polarity of induced EMF in a coil is given by Lenz's law, Faraday's law, Gauss law of magnetism, Ampere's circuital law. So polarity of induced EMF is given by obviously Lenz's law. Okay, the magnitude of the induced EMF is given by Faraday's law. The direction or polarity is given by Lenz's law. In a transformer, the windings of the primary and secondary coils are wound on a one over other to reduce the energy loss. So in a transformer, one coil is wound over another so that all the flask coming from the primary should pass through the secondary. So basically this is due to flask leakage. So here we are reducing flask leakage. Now you have to remember there are other types of leakage as well, and the names are given over here. So you have to study other possible losses and their remedies, so that in exam if they ask you any other loss related question, you can answer such question. So this is why I say model paper should be your guide. Okay, so model paper should be your guide. From here you get the hint that okay, they might ask a question from other types of losses. What is eddy current loss? What is hysteresis loss? How to reduce it? So these are the things that you have to study. Now, the electromagnetic waves suitable for radar system used in aircraft navigation are, so obviously in radar system we know that microwaves are used. Either microwaves or low frequency radio waves are commonly used. Okay, so microwaves are very commonly used in radar system. A ray of light incident on a glass air interface at an angle greater than the critical angle for pair of the media, then the ray undergoes. This is also very common question. I have discussed it multiple times. So the angle of incident is basically greater than critical angle, so it will reflect back. If it is equal to the critical angle, then it will be grazing the media. Okay, so the same question might come in your board exam, that saying that the angle is equal to critical angle. So in that case option D would be correct, that grazes the surface of the interface of the two media. But in this case they have said angle is greater than critical angle, so angle of incidence is greater than critical angle, so it will basically totally internally reflected. It will reflect totally, there is no partial reflection refraction. Other than that, if the angle is less than IC, that is the critical angle, then there will be partial reflection, partial refraction. Question number 11. To observe the sustained interference pattern on a screen placed at a suitable distance, Young's double slit experiment, which of the following conditions are necessary? Sources of light should be coherent. Yes, this is necessary condition. This is a necessary condition. Without coherent source, no Young's double slit experiment you can visit. You can see sources of the light should be narrow. The narrow light source should be narrow, because if they are not narrow, if they are not compatible with the wavelength of light, you will again not see any kind of interference pattern. Sources of light should be very close. Now this is a good to have condition, not a must have condition to observe Young's double slit. Now if they are super far away, then you might not see the Young's double slit experiment, because the light may not converge at that point. Okay, but they should be very close is a good to have condition, not a necessary condition. So this is why on both A and B is the answer for this. Okay, not all A, B, C, because sources should be very close is good for a good quality of interference. It is not necessary for a sustained interference. Okay, that is the difference. That is why this is a good to have condition, not a must have condition. There are two things, good to have, must have. For example, if you are appearing for the exam, you must pass the exam, that is the criteria. But good to have means if you score well in the exam, then your KCET rank, your future wherever you will go, they will say, oh, you got 99%, you got 95%, very good. So that is a good to have. But if you just pass, then this is necessary condition for your certificate, that he has passed the exam, right? So there are two things, one is good to have, one is must have. So these are the must have condition, this is a good to have condition. Okay, question number 12. The de Broglie wavelength of a moving particle is independent of dash of the particle. So the de Broglie wavelength is independent of the charge of the particle. We have solved this question also multiple times. So this is also easy question. For an electron revolving around the nucleus. So electron is revolving around the nucleus. Okay, let's see what they are saying. Kinetic energy and potential energy are positive, total energy is negative. Now kinetic energy, remember that, as I said, kinetic energy can never be negative. Kinetic energy is always a positive quantity. Potential energy can be negative, total energy can be negative, but kinetic energy is always positive. So in this case, kinetic energy is positive, potential energy and total energy are negative. Okay, so kinetic energy is always positive for any quantity, no matter electron moving in a orbit or a car moving in a road. Kinetic energy is always positive. Total energy and potential energy can be negative based on the location, based on the situation, but kinetic energy will always be positive. Remember that fact. This is a very important fact. While doing the live class for this question, many students answer all of them are negative. Okay, not all of them are negative. Kinetic energy can never be negative. The ratio of nuclear densities of aluminium 37 and copper 64. So if you see that they have given some weird elements, but you should remember that it does not matter whatever the question they have given. You should remember that nuclear density is constant for almost all quantities, and it is varying very slightly. Okay, so you can say that in this case the ratio of nuclear density is 1:1. Does not matter 27 or 64. Don't get confused. That is nuclear density is constant. Nuclear volume will vary, nuclear mass will vary, nuclear radius will vary, but density is constant. Okay, the ratio of mass by volume will remain constant. That is the most important fact. Now, the energy band gap in conductor, insulator and semiconductor are represented by respectively E1, E2 and E3. So E1 is conductor, E2 is insulator, okay, and E3 is semiconductor. So obviously we know that band gap for conductor is very small, it is almost equals to 0. So E1 must be the smallest. Okay, E1 must be the smallest. Now what about E3? E3 is basically E3 is between conductor and insulator. This is semiconductor, right? Last one is semiconductor, so be careful. So E3 is between conductor and insulator. So E3 will be greater than that of the conductor, but it will be less than that of the insulator. So insulator will be last. It has the highest band gap, highest gap energy, right? So E1 is less than E3, less than E2. So option D is the correct answer. So because it is a conductor, they will always have the lowest band gap, almost 0. Okay, some cases may be not 0, but 99.99 cases the band gap for a conductor is 0. Okay, whereas semiconductor generally has a band gap energy less than 3 electron volt, okay, but not 0. As you increase the temperature, the band gap energy reduces and it becomes a conductor. That is why they are called semiconductor, and under certain condition it becomes like a conductor. Other than that, it's a insulator. Now, next question. Now we have the fill in the blanks part. Okay, very interesting fill in the blanks for this question paper. One of the basic properties of electric charges. So whenever you are doing fill in the blanks, I always suggest to read the options first. Okay, first read the options, then read the question. So what is the option? Mutual induction, inductance, diffraction, magnification, quantization, interference. Okay, now read the question once more. One of the basic properties of electric charge. So electric charge, if you see all the options, only one thing which is related to electric charge, that is quantization. So the answer for this question will be definitely quantization. The ratio of magnetic flask linkage to the current in the coil is called the ratio of flask linkage and the current. So it can be mutual inductance or inductance. Okay, now if you remember that flask linkage is proportional to current. Okay, now if you differentiate this part, if you differentiate this, d phi b by dt is basically a constant k into di by dt. Okay, so if you see what is di by dt, di by dt is basically the inductance. So you say that the epsilon equals to k into epsilon by L. Okay, so L is basically k. The constant of proportionality is the inductance. It is called inductance. So because they are proportional to each other, the constant of proportionality is inductance. If you know it, very good. Other than that, you can skip it for now. You can check all the other options. You can come back to this, the last part. Okay, so inductance is the answer for this question. If you don't know it, you can skip it. Okay, you have to remember that di by dt, okay, epsilon equals to L di by dt. This is one line, and also you have to remember that epsilon equals to d phi b by dt. If you remember these two equations, if you compare them, the constant of proportionality becomes L. Okay, so this is what they are trying to find out, because the current passing through any coil is basically linked with its flask. Okay, the principal working of a transformer is, now we know this answer. Okay, so what is the principle? Any principle is given here. There are two. Diffraction is a principle, but diffraction is obviously not a working of a transformer. Interference is also not a transformer. Magnification is not a transformer property. So mutual inductance is the only answer to this question. So in the previous part, in mutual induction and inductance are making some fight between them. So after reading the question number 18, okay, you are sure that mutual inductance should be in case of transformer. So inductance must be for the previous one. Okay, a microscope is used to produce large dash of small objects. So if you are a bio student, if you have used microscope in laboratory, then you should know that microscopes are used for observing small objects which appears bigger when you see through the microscope. That means it basically magnifies. It basically magnifies the small object. So answer will be magnification in this part. So magnification is done, mutual inductance is done. The phenomena of bending of light around the edges of an obstacle is called. So now here we have two clear-cut options, interference and diffraction, but this is a very easy question in my opinion. So phenomena of bending of light around a sharp object is basically diffraction. We already know that, right? Interference is when two lights overlap. So two coherent sources of light overlap with each other, but bending, only solo light is happening only for diffraction. Okay, now let's move on to the two marker section. Name the two factors on which the resistance of a metallic wire depends. So what is the formula for resistance of a metallic wire? So resistance of a metallic wire is rho L by A. Okay, so this is the formula for metallic wire. So two factors are length of the wire, area of cross section, metal of the wire. Now you can mention that proportional, directly proportional to the length of the wire, inversely proportional to the area of cross section, and material of the wire is another part. Okay, but this question is too obvious. In the exam, what you will answer, instead of asking resistance, if they change the question to resistivity. So what you will answer then? So let me know in the main comment section below what will be your answer if the question is asked resistivity. If you have watched my all the other videos, then you should be able to answer it. I have discussed it in all 2 marker, 3 marker questions. If you have not watched that, go back and check that video as well once you have completed this video. When does a current carrying conductor placed in an uniform magnetic field experiences maximum force, minimum force? So we know that the force experienced by a charged particle is basically given by Q into V cross B, or this is in vector form, or in scalar form we can write the same as QVB sine theta. Okay, now Q is constant, V is constant, B is constant. Only thing that is changing is this theta, right? So when it will experience a maximum force, when sine theta is 1. So the force is maximum when the current is flowing perpendicular to the direction of magnetic field, that is theta is 90 degrees. Right, the force is maximum when sine theta is maximum. So sine theta is maximum at sine 90. So definitely sine 90 will be the answer for this. Minimum force is maximum, minimum, sorry, this will be minimum. Okay, when the current is following in the direction of the magnetic field. Minimum means sine theta 0. Sin theta 0 means theta is 0. That means current and so the flow is in the same direction as that of the magnetic field. So basically when they are in the same direction, then there will be no magnetic force. So if they are flowing in the same direction, theta is 0, then there will be no magnetic field, no magnetic force. Define magnetization of a sample. How is it related to magnetic intensity? So magnetization, this is a remember based question. So you can expect similar question from the chapter magnetism and matter, 1 2 marker question. So magnetism M of a sample is a measure of the net magnetic moment per unit volume of the material. M is net magnetic moment by volume. Okay, relation between magnetic intensity and magnetization is basically given by M is equal to chi H. Chi is called magnetic susceptibility. Okay, chi is written like, if you don't know, it is like this. It's like a X, but one arm of the X is little twisted. So you generally draw X like this, cross like this, whatever you say, cross X. So X is right like this, but here if you write both the ends are like this, then it is called chi. Okay, spelling is CHI, but while spelling it we say chi. Okay, now next. A boy pedals a stationary bicycle. The pedals of the bicycle are attached to a coil of 100 turns. Each turn of the area 0.2 meter square. The coil rotates at 6 rotations per second and it is placed in an uniform magnetic field of 0.01 Tesla, perpendicular to the axis of rotation of the coil. Calculate the maximum value of the EMF generated in the coil. So EMF generated in a coil is given by NAB omega. Okay, this is the formula. Now here if you see, the number of turns is given 100 turns. Okay, area is given 0.2 meter square, a magnetic field is given 0.1 Tesla, but omega is not given properly. It is given 6 rotations per second. Why I am saying omega is not given? If you just put the 6 value over here, you are thinking this is a very simple problem, I will get 2 marks. No, because 6 rotations is not omega. Okay, omega's unit is radians per second. Okay, 6 rotation means for 1 rotation the angle covered is 2 pi radians, right? For 6 rotations, how much angle is covered? 6 into 2 pi, that is 12 pi radians. So this is the angle covered. Okay, now this is the angle covered. Now what is the time for that? Per second. So radian per second is the angular speed. So omega is basically 12 radian per second, 12 pi radian per second. Now let's put the values one by one. N is 100, area is given 0.2, magnetic field is given 0.01, and omega is 12 pi. Okay, so the answer will be 220 into 0.01 is 0.2 again, so it will be 2.4 pi. Okay, so 2.4 pi will be the answer. Yes, so or you can use a calculator, 3.14 you can put the value and you can calculate the exact value that, but what is the unit? Unit will be in volts. Okay, so this is the induced EMF in the coil. Now here the problem has 2 parts. First part you have to show what is the value of omega, and the second part you have to use this formula to calculate. Okay, now from the 2 marker sections there can be possible different types of 2 marker questions. That's why I say focus on the theories first. For 2 marker at least you will be sure what type of question you can expect. Now next let's move on to the another question. What is the displacement current? Give the expression for it. Easy question. Let's see the answer. Displacement current, the current due to changing electric field is called displacement current, and its expression is ID equals to epsilon naught d phi e by dt. So ID is displacement current. Epsilon naught is free space permittivity, phi is electric flux, and T is time. Okay, so you have to mention these quantities as well, okay, to get the full marks. Now mention 2 uses of Polaroids. So let's see the uses. I have given you 3 uses so that in case the same question comes as a 3 marker, you can answer that. Okay, Polaroids are used to control the intensity in the sunglasses, window panes, etc. So if you see that window panes which may be one way through or which can reduce the light that is coming to your home, they are basically made up of some type of Polaroids. Polaroids are also used in photographic cameras and 3D movie cameras. So the camera that is used, they have some kind of Polaroid coating. Okay, also the 3D movie cameras where movies such as Avatar or Marvel movies are getting shot, those are basically 3D cameras and they have Polaroids inside it. And when you go to watch 3D movies, whatever 3D movie you have last watched, they also use the 3D cameras, 3D glasses, that the glass that you wear basically are Polaroid glasses. Okay. Write 2 limitations of Bohr's atomic model. Let's see. The Bohr model is applicable to hydrogenic atoms. It cannot be extended to even mere 2 electron atoms such as helium. Okay, so this is only for 1 electron system. Okay. While the Bohr model correctly predicts the frequencies of the light emitted by hydrogenic atoms. Now, hydrogenic atoms, why we are saying, just for your information, why we are not saying only hydrogen? Because hydrogenic atom means, if you say consider helium, okay, with +1 charge, or lithium with +2 charge, they are also hydrogenic atoms. Okay, so they only have 1 electron orbiting. Okay, so as long as there is only 1 electron orbiting, you can consider that to be hydrogenic atoms. Okay, that is why it is called, it is applicable to hydrogenic atoms. Now in these cases, it can explain the spectrums, but it cannot explain the spectrum relative, what they have said, cannot explain the relative intensities of the frequencies. So some cases, what we are expecting, okay, we are expecting that all the intensity should be equally same, all the intensity will be equally bright, but some cases we see some of them are very thin, whereas some of them are very thick and prominent. Okay, but some of them again are thick. So these things are not being able to explain by Bohr's theory. So what you are expecting, you are expecting that all of them will be either equally illuminated, or suppose first one is brighter, second one is slightly less brighter, then we get less brighter, like that. So it will be decreasing like that. But in the order of hydrogen spectrum, some light in between appears much brighter than whatever were there before or after. Okay, so these things are not being properly be able to explain by the Bohr theory. Secondly, the model does not explain the fine structure and splitting of spectral lines. So if you put a magnetic field or electric field around the hydrogen gas you are testing for the spectrum, you will observe multiple lines. Instead of a single line, this line will be split into 3. Okay, this type of splitting was not been able to explain by Bohr theory. Okay, so splitting of spectral lines observed under a magnetic field or electric field are not. These are names are optional, you don't need to write the names. Okay, but if you have to mention that splitting of spectral lines under the effect of magnetic or electric field is not been able to explain by Bohr's theory. How can a semiconductor diode be forward biased? What happens when what happens to the width of the depletion region when forward bias voltage is increased? Let's see. A semiconductor diode is forward biased when you connect the positive terminal of the power source, like a battery, to the P side of the diode, and the negative terminal of the battery to the N type side. Okay, you increase the forward bias voltage, the depletion region becomes narrower and slowly disappear. Okay, clear? Now derive the expression for the torque on a electric dipole placed in an uniform electric field. So we have some electric field. These are the small derivations that you have to practice. So we have a dipole, and we are trying to find what is the torque. How to do the torque? First of all, we have to identify, suppose this is the positive charge, this is the negative charge, both the charges are equal, right? Now positive charge will get experience of force in the direction of the electric field, say F plus, and the negative charge will experience a force in the direction opposite to that of the electric field, that will be F minus. Okay, the distance between the charges is obviously 2a. Okay, now because what is the force, F plus and F minus both will be equal in magnitude. F plus and F minus both will be equal to magnitude, and that magnitude, say F, will be equals to the charge into electric field. So this is the electric field E, right? Force is charge into electric field. By this time you should remember this at least one small equation, right? This is the force. Now how to calculate the torque? Torque is basically, if you have remembered some concept from your first view, torque is when two equal and opposite forces act on a system. Okay, the torque is basically magnitude of one of the force times the perpendicular distance between them. Okay, now the perpendicular distance in case of mechanics, when we solved in our first view, the distance was already perpendicular distance, but in this case the distance is not perpendicular. Okay, they have some angle, so you cannot simply say, okay, distance, what will be the distance? So distance will be, in this case, will be this will be the distance. This perpendicular distance means this is the distance. Now what is this distance? That distance, say L. Okay, if the dipole moment, which is from negative to positive, makes an angle theta with the electric field, then this angle will also be theta, parallel line. Okay, both are parallel, so this will be theta. So now from here, this is 2a, this distance we know 2a, this is L. So what is L equals to? So L equals to, this is the angle theta, perpendicular by hypotenuse, perpendicular is L will be 2a basically, that means 2a sine theta. Okay, so this is basically sine component of this. Okay, this one you have to remember. Okay, so torque is basically magnitude of any one of the forces times vector product, obviously, but vector product we are not using here, we are just saying force times the distance. Okay, force times the distance, that is F into L is the torque. So what is F? F is Q into E. What is L? L is 2a sine theta. Okay, so now let us write Q into 2a or 2a into Q E sine theta. Now what is 2a into Q? This is the dipole moment of the dipole. We already know that distance between the dipole times the charge, that is 2aq, is the dipole moment of the dipole. So from there you can write this as Pe sine theta. Now Pe sine theta is basically what we can write in terms of vector form. You can write it as P cross E. This is the expression for torque acting on a dipole kept in an external electric field. Small easy derivation, you have to remember and write these steps as well. If you write these steps, definitely you will get full marks from this. This is a 3-marker question and easy also. Give the results of electrostatics of conductor. This is a very uncommon question, never came. Based on these concepts, objective questions used to come, 1 marker previously when it was 1 marker question, and MCQ question used to come. But now they have directly asked, give 3 results of electrostatics in conductors. But you cannot skip it. Obviously, if the same question comes in your board exam, you cannot say that this was sir said this was uncommon question, but board will say, haha, this was part of your model question paper, so you cannot skip it. Yes, you cannot skip the model question paper. Inside a conductor, electrostatic field is 0. Obviously, inside a conductor, electrostatic field is 0. At the surface of the charged conductor, electrostatic field must be normal to the surface at every point. So electrostatic field at the surface must be normal to the electric field must be normal to the surface at every point. Okay, inside a conductor, excess charge is zero in static situation. So in static situation means you are it is a static electricity you are considering, no flowing charges there. Okay, and excess charge means what? Obviously there will be some electrons, there will be some protons as a part of the nucleus. Okay, that you cannot consider to be zero. Excess charge means if you add any extra charge, only some few extra electrons. Okay, so people think that whatever charge inside a conductor, all the charge stays in outside. No, only the excess charge stays in the outside. Okay, whatever extra charge if you give electrons, or if you take out electrons, whatever you do, that extra charge basically stays outside on the surface. But internal atoms will already have positive and negative charges. So you cannot say that inside is void of charge. There are some charges. Okay, now state and explain Biot-Savart's law with a suitable diagram. Let's see, this one also we have seen multiple times. This is the diagram. We have to draw one rod that is any shape. This is just to show you, okay, so that you can draw the tangent for this. Okay, and this is just a fancy diagram. That does not mean you have to draw the same diagram, but I know all of you will draw this diagram only. So anyway, so let's see what are all the things. So the first thing is the magnitude of the magnetic field dB at a point P due to a current carrying element dl is given by, is basically proportional to current I, proportional to current element dl, proportional to the angle theta made by the current element, and the position vector, and it is inversely proportional to square of the distance. If you combine everything, you will get the combined equation, which is dB equals to mu naught by 4 pi I dl r divided by r square sine theta. Okay, this is the Biot-Savart's law. If you write it, it is very, very good. Now write the three differences between diamagnetic and ferromagnetic material. So I gave you a complete table in our 2-3 marker section, where I have discussed in the passing package also I have given a complete, in the passing package in fact I have given a better representation, where diamagnetic, ferromagnetic, paramagnetic, all the three differences table in one shot, right? So that any of the two differences are very likely to come. Okay, any two combination. Okay, 3 of them are there. So how many combinations, you tell me in the combination permutation chapters if you have studied it. Only combination is there, no permutation. So magnetic field behavior, magnetic susceptibility, effect in a magnetic field. These are the 3 properties. The weakly repelled by the magnetic field, they are strongly attracted by magnetic field. Okay, now magnetic susceptibility, have a small negative magnetic susceptibility, have a large positive magnetic susceptibility. Effect in a magnetic field, increases magnetic moment at the opposite direction of the applied field, introduces a strong magnetic moment in the same direction of the applied field. So these are the basic properties. So for diamagnetic, chi is 0, for paramagnetic, chi is positive but very small, for ferromagnetic, chi is very, very large. Okay, these are the basic difference you have to remember. Now let's look into question number 33. Derive an expression for motional EMF induced in a straight conductor moving perpendicular to uniform magnetic field. So very, very common question. So first you have to draw the diagram like this. So here we have a frame and the magnetic field is into the page of the paper, and the rod is moving in the perpendicular direction to the velocity. Velocity vector is perpendicular to the magnetic field, right? So first of all, how can we calculate the induced EMFs? To calculate induced EMF, first we have to find the magnetic flask. So what is magnetic flask? Magnetic flask is nothing but phi b. Phi b is magnetic field times area. So what is magnetic field here? Magnetic field, I assume the magnetic field is already given, constant magnetic field B. What is area in this case? If you see the diagram, the area is very clear. It is length into breadth, that is length L into breadth X. So it will be L into X. So this is the magnetic flux linked with this loop, right? So magnetic flux linked with this loop is BLX. So what is the induced EMF from Faraday's law? Ignoring the negative sign, we can write the magnitude of EMF is given by magnitude. Remember that this is magnitude, okay, because there is a negative sign here. We are not considering the negative sign. So now if you see that B is constant, this value L is also constant, right? Only thing that is changing is this X distance, right? So while differentiating phi B, B and L are constant, so they will come out of the differentiation only. Which is changing with time will remain in the differentiation, right? Differentiation means with change with respect to something, right? So in this case, as B and L are constant, they will come out. So dx by dt. So what is dx by dt? If you remember your first PUC class, dx by dt is nothing but the velocity v. So induced EMF is BLV because v equals to dx by dt, as simple as that. So this is the induced EMF, this is the expression for induced EMF, motional EMF, right? Simple equation, simple calculation. Only you have to draw this diagram and briefly explain. The length is L and at some time it is at a distance x from the other end, right? That is the sufficient for the 3 marks. Now let's move on to question number 34. A small candle is placed at a distance of 20 centimeter in front of a concave mirror of radius of curvature 30 centimeter. So radius of curvature of the concave mirror is given by 30 centimeter. Now this is radius of curvature and it is a concave mirror, so the sign is negative. For a concave mirror, the sign is always negative, so the focal length is basically radius of curvature divided by 2, that is minus 15 centimeter. So focal length is calculated. The distance is 20 centimeter. The object distance is always negative, which is 20 centimeter. Okay. At what distance the mirror should a screen be placed in order to obtain a sharp image? So we have to find V. Okay, we have to find V and what is the nature of the image. So let's solve it. So we know that mirror equation 1 by V plus 1 by U equals to 1 by F. Okay, so what is 1 by V? 1 by V we are trying to find. So 1 by V equals to 1 by F minus 1 by U, or you will get UF U minus F, okay, or V equals to UF divided by U minus F. If you do this mathematics before you put in the values, your time and your calculations are much more effective and you can expect the errors that you might have while putting in the values, they will be reduced by a lot, okay. So because I have seen student calculating 1 by V, they leave the answer at 1 by V. They forget that you have to take the reciprocal of that. So what is U? U is minus 20. Don't forget the signs. Signs are very, very important. F is minus 15 divided by U is again minus 20. F is minus 15. Okay. So this minus and this minus cancel, minus minus plus, but in the denominator this and this minus minus will become plus. We will see that. So 20 into 15, no need to multiply yet, minus 20 plus 15. Why plus 15? Because minus minus plus. So minus 20 plus 15 is minus 5. So there is only one minus, so that minus will be, we can write it outside of this calculation. Okay, so there was one minus over here, right? Minus 20 plus 15. So that minus I have written it over here. So 3 5s are 15. So it will be minus 60 centimeter. Okay, so minus 60 centimeter at a distance 60 centimeter from the mirror. Okay, and because the sign of the object image distance is negative, that means what happened in case of mirror. Okay, this is the mirror, right? So object was here, so this was your f, this was your object, and this was your 2f, right? So object was somewhere here. So as we know that object distance was negative, now image distance is also negative, so that means image is also on the same side as the object. So this is a real object, real image. So image is real image. In fact, you can write it is real, inverted, and enlarged image, right? Everything is the nature. But real is compulsory. Real you have to mention. Real, inverted, and enlarged. Okay, because you can calculate the magnification, not required, but you can see that the object is placed between f and 2f. So if you place an object between f and 2f, you get a enlarged image, right? And obviously real image means it will be inverted. Using Huygens principle, show that the angle of reflection is equal to angle of incidence when the plane wavefront is reflected by a plane surface. Now this is a 3-marker question. So we have a surface. So this is the ray of light falling. Okay, now when the light ray from here, suppose this is ray number 1, this is ray number 2, when the ray 1 reached the mirror, okay, the ray 2 was still at this point. So this is say point A, this is point B. Okay, so when the light was at point A, the light from the ray 2 was at B. So this is the incident wavefront. Incident wavefront means this angle is incident angle. Now you can draw the this one also. This will be incident angle. Now this will be reflected angle. You have to show that angle of incidence equals to angle of reflection. Now by the time the ray of light sorry, there is a small mistake here. Okay, I marked the angle of reflection wrong. Okay, suppose this is the ray, this is another ray. Okay, so this is the perpendicular distance. If you have to draw a perpendicular, okay, this angle should be perpendicular. So this is when the ray was at ray 1 as at point A, ray 2 is at point B. Okay, this is the mirror. Now this will be the angle of incidence I. Now what will be the angle of reflection? Angle of obviously light ray will reflect at some different angle, so this will be the reflected ray, and by the time the ray reaches over here, this ray reaches say at this point. Okay, now so this will be the reflected wavefront. Let me use a different color. So this is the reflected wavefront, so the angle of reflection will be R. Okay, now you also can draw the normal. This is I, this will be R. No required, but better to show that in the diagram. And for this derivation, diagram is compulsory. Without diagram you will not get any marks. Okay, so what you have to show that this I is equals to R. Okay, that is the main objective of our derivation. So first of all, the speed of light in this medium is constant, and say that is V. Okay, so by the time the light ray reaches from A to say D, point D, this is C. By the time the light reaches from A to D, from light B it reaches to the point C. So BC and AD are equal. How to show that? So AD is basically speed of light into time taken, right? Similarly, BC is also V into T, same time, right? So light ray, when it is reaching from A to D, then in the same time light is reaching from B to C. Okay, so AD equals to VT, BC is also equals to VT. So from there we can write AD equals to BC. Now you have to consider the triangle ADC, triangle ADC, and triangle ABC. Okay, these are the two triangles because the top angle is 90 degree. So what are all the things? So AD equals to BC, and angle ADC, ADC equals to angle ABC, both are 90 degrees, right? So both angles are 90 degrees. Now what else? This AC side is common. So so this side and this side are equal and this angle is equal. So side angle, or angle side angle, not side angle side. In one of my previous videos I said side angle side. Side angle side is when two sides and their in between angles are equal, then we say side angle side, but it is not like that. So it will be side angle side by side angle. Triangle ADC is congruent to triangle ABC. So what is the meaning of congruent? Congruent means all the similar angles should be equal. So that means DCA, angle DCA should be equals to angle BAC, or angle R equals to angle I, or angle I equals to angle R. Okay. So this is the simple derivation, easy derivation. That is why it is a 3-marker question. If this question comes in a 5-marker section, then there will be another 2-marker part that state and explain Huygens principle. So that will be there in a 5-marker question. Okay. Now let's move on. Write 3 features of nuclear force. So let's see the 3 features. The nuclear force is much stronger than the Coulomb force acting between charges or the gravitational forces between the masses. Okay, the nuclear force between two nucleons falls rapidly to 0 as their distance is more than a few femtometers. Okay, so nuclear force clearly works up to 0.8 femtometers. Okay, that is up to that range it is attractive. After that slowly it becomes 0. Okay. The nuclear force between neutron-neutron, proton-neutron and proton-proton is approximately the same. The nuclear force does not depend on the electric charge. So nuclear force is independent of the charge. Okay, and force between any two particles, any two nucleon is same. Now let's move on. Now it's a derivation part. So first is state Gauss law in electrostatics. Derive an expression for the electric field at the point due to an infinitely long, thin, uniformly charged straight wire using Gauss law. So this is the statement of the Gauss law. Statement: total electric flux through a closed surface in air is equals to 1 by epsilon naught times the total charge enclosed by that surface. So flask is basically the definition of flask is E dot ds. Okay, so integral of E dot ds, and that is given by Q by epsilon naught from Gauss law. So this is the entirety of the Gauss law. You have to write it down and write this formula as well. Okay, now we have to look into the derivation. So derivation is a uniformly thin rod. I have done this. This is one of my top recommendation from this chapter for derivation. So you have to practice it multiple times to you should not make any mistakes. These are a very common question. Okay, so this is the say positively charged, uniformly charged, infinitely long rod. Okay, so what is the meaning of uniformly charged? Uniformly charged means the charge per unit length is constant, so lambda is constant. Now we are trying to find electric field, say at a distance r. Okay, so what we will do, first stage is to construct a Gaussian surface, okay, of radius r. Now electric field in this direction is 0, only electric field is perpendicular, so this is the direction of electric field, and due to cylindrical symmetry, electric field will be constant at the all points on the surface of the cylinder, right? So electric field will be constant. So from Gauss law we can write that. Now if the length of this entire cylinder is L, then what is the charge enclosed? First of all, you have to find the charge enclosed. So charge enclosed is basically length times charge per unit length, right? That is the definition. So L lambda is the total charge enclosed by this Gauss cylinder, Gaussian surface. Okay, now Gauss law states that close integral E dot ds equals to Q enclosed by epsilon naught. Now due to cylindrical symmetry, obviously E will be constant, so magnitude of E will be constant, so E dot ds will become normal E ds, and Qn we can put the value lambda L by epsilon naught. Now what is ds here? Ds means total surface area. Integral, cross integral ds means you are taking small areas and adding all the areas. That means you are getting the total surface area. Now what is the total surface area of a cylinder? So if you cut the cylinder and if you stretch it, you find the total area of the cylinder, right? So total area of the cylinder, basically it's like a rectangle. So it is 2 pi r of length and L is the height, so 2 pi r into L is the total surface area. So you get E into 2 pi r L. This is the area, right? So you get L lambda by epsilon naught. Now L cancels, so you get electric field E equals to 1 by 2 pi epsilon naught lambda by r. Okay, just organized it little bit. This is the expression. If you do this derivation, very simple, easy derivation, 5 marks guaranteed. Slightly write up you have to do. Just you have to add that due to cylindrical symmetry, electric field is constant, and in the top you have to write let us construct a Gaussian surface. I have discussed this in my derivation video. If you have not watched that, you can go and check that out. Now arrive at the balanced condition of Wheatstone bridge using Kirchhoff's laws. Another very common question. So there is a Wheatstone bridge. Right, so four resistances P, Q, R, S are there. Current through the P part is I1, and then it is moving with I1 minus Ig to R, and remaining Ig current is passing through the galvanometer. Now I2 current is passing through Q and it is meeting up with Ig, and now the current is I2 minus Ig for S. Now we have to consider two loops. First loop is this one, loop number 1, and this is the second loop, loop number 2. So from loop 1, how to calculate the how to apply KVL. KVL is basically current times the resistance. Okay, current times the resistance I1P, and if you have to start at some point and you have to continue going in the same direction. Okay, always you have to try to close the loop and you have to move in the same direction. So after going up to this point, you cannot say, okay, I have reached this point, now I will go in the opposite direction. That is not allowed. Okay, or you reach this point, then you will say, okay, I will again start from here and I will go to this point like this. That is also not allowed. So you have to go in the same direction and close the loop. So this is the smallest possible path to close the loop. So I1P into Ig into G. Ig into G, if you see, this is also in the same direction. So Ig into G minus, now when you are going from this point to this point, you are going in this direction, but the current is flowing in the opposite direction. So I2 into Q will be opposite. So I2 into Q, and that should be equals to 0, because in this loop there is no battery connected. Battery is connected outside this loop, so that will not affect this entire thing. So voltage will be 0. Now we will go in this loop. Whatever I will start, I generally like to start from here. So this point to this point, then this point to this point, then this point to this point. So we will start or start here. This is the easier point. So loop 2, we will start here. Ig into G from loop 2 ig into g, okay, plus I2 plus g into s minus why minus? Because now we are going from here to here, closing the loop, so that will be I1 minus ig into r. Okay, so this is equation 1, this is equation 2. This is, we are applying Kirchhoff's laws. Now for balanced condition, what is the balanced condition? Ig must be equals to 0. So what you have to do? You have to put Ig equals to 0 in both of the equations. So from equation 1, what we get? From equation 1 we get I1 into P minus I2 into Q equals to 0, or I1 into P equals to I2 into Q, or P by Q equals to I2 by I1. Okay, similarly from equation 2, if you put Ig equals to 0 there, what you will get? You will get R by S equals to I2 by I1. Okay, you can check that out. Otherwise you can similarly write, this is also fine if you write similarly. Okay, so this is now equation 3, this is 4. So comparing 3 and 4, we get P by Q equals to R by S. Okay, comparing. Okay, so this is the correct derivation. So just this derivation and you will get full 5 marks. Easy derivation. We were expecting this derivation to come in last year, but it didn't came. So maybe you will get lucky and that will come in your current year. Now this is something which is not there in your previous year question papers. I have not seen this in any of the papers. This is something new question which came only this year's model question paper. But if this question comes, what to do? So what is the principle behind working of a moving coil galvanometer? So principle of a moving coil galvanometer is that when current carrying coil is placed in the uniform magnetic field, it experiences a torque. As simple as that. Now with the help of a neat level diagram, obtain the expression for angle of deflection produced in a moving coil galvanometer. And that part is very easy. The diagram part, you have to draw a simplified diagram of this. This is the diagram given in your textbook. This is the diagram for a moving coil galvanometer. Now moving coil galvanometer works under the principle is that when it is placed in the magnetic field, it experiences a torque, right? That is what written here. So torque is what? Torque is M into B. Okay, torque is basically M into B. Now angle is angle is immaterial here because angle is 90 degrees, so M B sin theta, so sin 90 is 1, so angle is not required, so tau is equal to MB. Now what is M here? If number of turns is N, then it is NIA. IA is normally for one single loop, but here we have multiple number of turns, so for n number of turns it is NIA, so NIAB is the torque. Okay, NIAB, simple. The derivation is very simple. Now what is torque? So if you remember, if the moment of inertia is I and angle of deflection is theta, then torque is basically I into theta. Okay, torque is I into theta. Okay, and from there you can say that theta equals to N AB by I. So one more thing, because there are two I's, one I is current, another I is moment of inertia. Let me write this as K. Okay, so let me write this as K because the angle with which it deflects is basically proportional to theta, so proportionally constant, we can say this is K. Okay, does not matter because to avoid confusion, so it will be NAB by K into I. This is the expression for angle of deflection. As simple, very easy question. If this question comes, every student will score out of out. Okay, even though the question is very uncommon, but derivation has no mathematics in it, only one simple equation, that tau is equal to mb and tau is proportional to theta. So this is k is constant of proportionality. Only you have to write that constant of proportionality. Right, and this diagram you have to draw. Okay, the diagram are not as complex as that, but a simple version of this diagram you have to draw. Okay, now let's see, derive an expression for refractive index of material of the prism in terms of angle of minimum deviation and angle of the prism. Let's see the derivation part. First of all, you have to draw these two diagrams. These are very common expected question, but the diagrams you have to draw it. Okay, these two diagrams, both diagrams are compulsory. Okay, now let's see the derivation. From geometry of this we get delta equals to I plus E minus A. That can be proven from geometry, but you have to remember it. Better to remember than try to find out the relationship. Okay, now also angle of prism is basically R1 plus R2. Now by observing the I versus delta graph, we can see that at the angle of minimum deviation occurs when angle of incidence I is equal to emergent angle E, that is E equals to I and R1 plus R2 equals to R, right? So if E is equals to I, that means when minimum deviation occurs when this angle this side and they are having same value. Other than that, for all possible points you see 2 points. So this is I, suppose this is I, then this will be E. But only at this point when the angle of deviation is minimum, this is the minimum possible value, right? It cannot go anything below than that, right? So that is why it is called angle of minimum deviation, and at this point, as you can see, only one value of I is possible. So I and E are equal at this point. So that is the thing that we have done. Now if incident angle are refracted incident angle and refracted, I mean emergent angle are equal, then definitely internal angles will also be equal because refractive index is constant, right? So delta m is given by 2I minus A, or I can be written as A plus delta m by 2. Similarly, you can write R is basically A by 2. Okay, so from here you can write R equals to A by 2. So now what is the refractive index? Refractive index is basically n21 equals to sin I by sin R, or you can say that n21 is equal to sin, instead of I put this value, instead of R put this value, so it becomes A plus delta m by 2 into sin A by 2. So this is the entire derivation, process based derivation. Okay, slightly remembering, you have to do, the diagrams are easy to be drawn, not super difficult diagrams, but you have to practice it. Okay, how to draw the incident angle, okay, then how to draw the dotted line so that they meet at a point, and you have to mark the delta here, mark I, mark E, R1, R2, everything has to be marked along with the angle of the prism A. Okay, this is the angle of prism A. Okay, now write three differences between intrinsic semiconductor and extrinsic semiconductor. Draw the energy band diagram of one n-type, two p-type semiconductors at temperature T greater than 0 Kelvin. So let's see. So definition is a pure semiconductor with no impurities, a semiconductor doped with small amount of impurity to improve the conductivity. Charge carriers, equal number of electrons and holes, unequal number of charge carriers. Majority carriers electron is n-type, hole is p-type, and minority carrier. So do we have two types of extrinsic semiconductors? Intrinsic semiconductors are generally the same. Conductivity, low conductivity at room temperature, high conductivity at room temperature. Okay, because due to doping the conductivity increases. Okay, so these are the basic difference between conductors and insulators. This is the energy band diagram. This is the diagram for n-type. Okay, this is the n-type diagram, and this is p-type diagram. okay, and temperature is greater than 0 for both cases. So what is important here, you have to show that this is the energy gap. Now when you are adding the impurity, what is happening, there is a additional donor level which is appearing, and because of this donor energy level, the band gap, effective band gap is now only 0.01 electron volt, so electron can easily jump to the conduction band. Okay, whereas in case of p-type semiconductor, as you can see, there is an additional acceptor level is appearing which is accepting electrons, and because of that there are a lot of holes are getting created here. Okay, now it's time for to solve the numerical questions. So numerical questions in this paper are slightly different genre. So let's see, 3 capacitors of capacitances 2 microfarad, 3 microfarad, 6 microfarad are connected in series. So we have 3 capacitors 2 microfarad, then we have 3 microfarad, and we have 6 microfarad. Okay, so 2, 3 and 6 microfarad are connected in series. 2, 3 and 6. Now what is the equivalent combination, what is the effective capacitance of the combination? So effective combination means equivalent capacitance. So when capacitance are connected in series, the equivalent capacitance is basically 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Okay, because they are connected in series. So in series, capacitance is basically opposite. So here you will get 1 by 2 plus 3 plus 6, 1 by 2 plus 1 by 3 plus 1 by 6. So the LCM is 6. So it will be 3 2s are 6, 2 3s are 6 plus 6 1s are 6. So this is 1 by C equivalent. Remember that this is 1 by C equivalent. So 3 plus 2 is 5, 5 plus 1 is 6, so 6 by 6. So basically this is 1. Now C equivalent is 1. What was the unit? Microfarad. This is the equivalent EMF. First part, this is part A. Now what is the next part? Find the potential difference across 6 microfarad capacitor if the combination is connected to a 60 volt supply. Now if the combination is connected to a 60 volt supply, what will be the charge or potential difference, basically what will be the potential difference across this? So V1. Okay, now remember that in series combination the charge through all the capacitors remains the same. Okay, in fact if you draw the equivalent circuit diagram, then also the charge will remain the same. So that will be our starting point. First we will use this equivalent capacitance to find the charge. Okay, then using that charge Q is equal to CV, we will find the voltage across this 6 volt capacitor. Okay, so first we will this is part B now. This is part A. First we will calculate the charge. So first we will use this capacitance and the same formula, that is C equivalent into V is equal to Q. Q is equal to CV, right? So what is Q? 1 microfarad. Microfarad, even though it does not matter, but we have to put the values because we are doing some calculations. Voltage is 60 volt. Okay, so this much coulomb charge is flowing in the circuit. Now we will use the same formula, but here we will use only the 6 microfarad capacitance. For 6 microfarad capacitance, Q equals to 6 microfarad into 10 to the power minus 6, and voltage now we are saying V1, so that will be V1. So we will put this value. Now instead of Q over here, we will put this Q. Okay, so 1 into 10 to the power of minus 6 into 60 equals to 6 into 10 to the power of minus 6 into V1. Okay, so 10 to the power of minus 6 cancels, 6 cancels, it will be 10, so V1 equals to 10 volt. Easy as you can get. Very simple, very easy. That is why I say that if you practice few problems from electric charges and field and electric potential and capacitance, you can solve all the questions. Okay, let's move on. For copper, the number density of free electrons is 8.5 into 10 to the power of 28 meter to the power minus 3, and resistivity is 1.7 into 10 to the power of minus 8 ohm meter. Calculate the conductivity of the copper wire and the relaxation time of the free electrons in the copper. In copper, take the mass of the electron is 9.1 into 10 to the minus 31 kilograms and E is 1.6 into 10 to the power of minus 19 coulomb. So first of all, we have to calculate the conductivity. So what is the formula for conductivity? Conductivity is basically given by 1 by rho. Rho is resistivity, which is given 1.7 into 10 to the power of minus 8. So conductivity is very easy to remember. It is basically 1 upon resistivity. Now this is a very uncommon question, never came in previous year questions, and it is obviously calculation heavy question, as you can expect. So if you calculate it, I think you will get 5 point something into 10 to the power of 5.880, if I am not mistaken, 10 to the power of 7 Siemens per meter. So unit of resistivity is ohm meter, and unit of conductivity is Siemens per meter, capital S per meter, or you can write ohm to the power minus 1, meter to the power minus 1. That is also fine, acceptable. Okay, Siemens means ohm to the power minus 1. Okay, so this is the formula, but the next part is tricky. You have to remember the expression for relaxation time in terms of conductivity and other terms. So it is ohm meter sigma m divided by n e square. So relaxation time is basically sigma m by n e square. It comes from the fact that sigma is equals to n e square by m into tau. So this is the formula, this is the mother formula. From here you have to remember this equation. Okay, so that is why there are different in this part, especially in the drift velocity and relaxation time part, there are 7 to 8 different formulas that you have to remember. So any one of the formula based on question can come. So either you can skip this question. So that is why I do not recommend questions from the current electricity chapter. If it is circuit theory based question, yes, there is a 99% probability that the question from this chapter will be circuit theory based question, but 1% probability is there. It will be some formula, some obscure formula which is not very commonly used. That type of formula based question might come as well. So as you can see here it is, so you have to put the values. 5.88, mass is 9 into 10 to the power of 7, obviously, into 10 to the power of 7 into mass is 9.1 into 10 to the power of minus 31, and n number density is 8.5 into 10 to the power of 28, and then 1.6 into 10 to the power of minus 19, okay, whole square. So if you calculate it, you will get some value. Okay, I think some 10 to the power of minus 14. I think 2.4 into 10 to the power of minus 14, if I am not mistaken. 21, 10, 21, 14. Yes, 2.4 into 10 to the power of 14 seconds would be the answer. Okay. So again, it will not take much time if you know these formulas, and if you put the values and calculate them using your calculator without any mistake, then it will be a perfect answer. But if you don't remember these formulas, which is very rarely used, okay, so that is why I don't recommend questions from this chapter. Also, you have to put all the values, multiply properly, do the 10 to the power calculations properly. Okay, there is a 1.6 whole square. So most of the students will miss out this whole square. They will say they will cancel 10 to the power of minus 19. If you do the whole square, it will not only become 2.56, it will also become 10 to the power of minus 38. So that you have to be careful about. Okay, so that is why I say these problems are little bit tricky. Now next part is my recommended chapter, alternating current, but this problem is slightly difficult, slightly tricky, but you can still get marks even if you don't know, if you don't correct it properly. Okay, first of all, a resistor 50 ohm, a pure inductor of 250 millihenry and a capacitor are in series in a circuit containing an AC source of 220 volt 50 hertz. Okay, in the circuit, current leads the voltage by 60 degree. Current leads the voltage means XC is greater than XL. Current lead means XC is less than that of XL, or XC is greater than that of XL, or XL is less than that of XC. This is the simple fact. Okay, if the current lags, then XL would be greater. Now the first of all, obviously, as I said, R is given 50 ohm, nothing to do with R. First step is XL you can calculate. XC we have to find, because we are trying to find the capacitance, right? To find the capacitance, we have to find the excuse me, we have to find the XC first. Before even going into that, we have to calculate the XL. XL is 2 pi F into L. 2 pi into 50 into L is 250 millihenry. 250 millihenry means 10 to the power of minus 3. Milli means 10 to the power of minus 3. So it will be 500 into 250 into 10 to the power of minus 3 pi. Pi is there. Okay, so we will try to reduce it. 10 to the power of minus 3. How many zeros are there? 1, 2, 3 zeros are there. So they will cancel. So it will be 25 pi. So XL is 25 pi. Okay, you can put the values. It will be 75 point something, 78 point something, if I am not mistaken. 25 into 3.14, right? No, 75. It will be 75 point something. No, it will be 78. My mistake. It will be 78 point something. Okay, so 78 is the XL value of XL. Now we have to calculate. First we have to find XC, from there we have to find C. So what is given here? The phase difference is given. Phase difference is basically tan inverse. Okay, tan inverse bigger minus smaller. You have to remember that it is bigger minus smaller. What is who is bigger here? XC is bigger. So XC minus XL. Okay, if it was opposite, that is current was lagging, then formula would be XL minus XC. Always remember that, bigger minus smaller. So this is very important. So that is why I said this is slightly trickier than usual question. Okay, so phase difference is given. Not only that, current leads is given. Okay, current leads means XC is greater. Okay, but you have to remember there are very few particular type of problems. So XC minus XL by R equals to tan phi. Okay, equals to tan phi. Now what is phi? Phi is 60 degrees. So tan 60 degree. What is tan 60 degree? Tan 60 degree means root 3. Right? So now XL minus XC, XC minus XL, that is 78 approximately equals to root 3 into 50 or 50 root 3. Okay, 50 root 3. Okay, or XC equals to 50 root 3 plus 78, which will be almost equals to 165. Okay, 165 ohm. Unit of reactance capacitance are ohm. So this is the XC. Now how to calculate C? C will be, what is XC? XC is 1 by 2 pi FC. So C will be 1 by 2 pi F XC. You put the value, you will calculate the value of capacitance, which will be if you put the values properly and calculate it, it will be 19 point something, 10 to the power of minus 6, that is 19 microfarad. It will be the answer. Okay, so you can check that out if you put the values. It is obviously this process based. If you calculate XL properly and if you calculate XC properly, you can get almost 4 marks. Okay, final calculation of this, if you even if you don't remember it, you can still get 4 marks if you calculate it properly. Now this is very important to remember, this part, this formula. Okay, so because XC is greater, because current leads, so it will be XC minus XL. That's it. Okay, otherwise it will get a negative value. So don't do that, be careful, don't make any mistakes here. Now next is, when the light of wavelength, this is also a completely new question. All other blueprints have different questions from ray optics, but only model paper 3 has a question from wave theory of light. So when light of wavelength 400 nanometer is incident on a photosensitive surface, the stopping potential for the photoelectrons emitted is found to be 0.96 volt. When the light of wavelength 500 nanometer is incident on the same photosensitive material, the stopping potential is found to be 0.034 volt. Calculate the Planck's constant given the speed of light in vacuum is this. E is this. Now even though the question is tricky, you don't need to do a lot of mathematical calculations in terms of in the previous questions, right? First of all, there is only one formula, that is EV0 equals to H nu minus phi. Okay, this is the main formula that we are going to use here. Okay, so EV0 is the stopping potential, V0 is obviously the stopping potential, and phi is the work function. Work functions remains constant for the material, right? So first let us convert it into something which is given in the question, Hc by lambda minus phi. So because lambda is given, wavelength is given, okay, we have to convert it into this equation, Hc by lambda form. Now what? First, for first wavelength, okay, it is given EV01 equals to Hc by lambda 1 minus phi. And for number 2, the same thing, EV02 equals to Hc by lambda 2 minus phi. Okay, so these are the two equations that you have to put. Now you have to just subtract them. Okay, so it is obviously the values are given. We will put that values one by one, but first we will try to eliminate this phi. So Hc is common, Hc coming out, so you get 1 by lambda 1 minus 1 by lambda 2. So first we will calculate this one, then we will put the values. So what is 1 by lambda 1? 1 by lambda 1 minus 1 by lambda 2, that is 1 by 400 nanometers. 400 nanometers means 10 to the power of 9. Okay, nanometers means 10 to the power of minus 9. So 1 by 400 into 10 to the power of 9 means the 10 to the power of 9 will go up. And minus 1 by lambda 2, lambda 2 is 500 nanometer. So again it will be 10 to the power of 9 by 500 nanometers. So if you see, there are two zeros both cases, so you can slightly reduce it. So 10 to the power of 7 by 4 minus 10 to the power of 7 by 5. So we have just reduced two of the zeros. So now we can take that 10 to the power 7 as common and do the subtraction. So 5 4s are 20, 5 4s are 20, and minus 4 5s are 20, so 5 minus 4. So what you get? You get this equals to 10 to the power of 7 by 20. Right? So 5 minus 4 is 1. So 1 into 10 to the power 7 is 10 to the power of 7, and there is a 20 in the division, so 20. This is the main thing that we have to solve. Now we have to put the values. So E is 1.6 into 10 to the power of minus 19. V01 is given 0.96 and V02 is given 0.34. H we are trying to find, calculate. C is 3 into 10 to the power of 8, and this one is 10 to the power of 7 by 20. Okay, so now we can calculate H equals to this entire thing, that is 1.6 into 10 to the power of minus 19 into 0.96 minus 0.34 is 0.62. So 0.62, and then this 20 will come up. So on this side, this is the left hand side. Now we have to take care of this also. This will come here as a division. Now if this comes as a division over here, this 20 will go up, divided by this entire thing, 3 into 10 to the power of 8 plus 7, that is 15. Okay, so if you calculate the entire thing, we know the Planck's constant is approximately equals to 6.6 into 10 to the power of minus 34 joules second. That is the unit. So the unit is very, very essential. So as I said, mathematically only one part that you have to calculate is this part. Okay, other than that, everything you can, after writing the equations, if you properly write the equation, the entire value will be coming up quite nicely. But this is an example problem. Definitely this problem will not come in your board exam. So it will be very surprising to see if you see the exact question in your board exam. But if a question comes from dual nature of wave and light, then only this formula is sufficient. Okay, there are another formula, that is kinetic energy. Kinetic energy is h nu minus phi, or half mv square, okay, is equals to h nu minus phi. So these are the equations that you might need to solve any question from this equation. Okay, and obviously phi is equals to h nu naught. So these are the one equation. There are 4 varieties of the same equation. Based on the same variety, same value of the equation, the problem might come. So that is why I think if you just remember the different varieties of the equation, same equation, okay, you might be able to solve a numerical if the question paper is slightly offbeat. Okay, so that is one hint that I gave you. How to solve such questions, right? With this, I will be wrapping up this model question paper 3. I will be doing a lot of other videos very soon, and let me know how is your preparation going on for upcoming physics exam. Till then, bye.